So far, we discuss and we learn a lot of techniques, more and less or less complex and advanced techniques. And it is time to start in the last 3 chapters. We'll discuss the most advanced techniques and most recent developments in the area of predictive analytics and business forecasting. It was about the end of the last century and beginning of the current one when some new terms and areas in the science appeared. As a matter of fact, they existed a long time ago, but these areas of the science and research, they were not separated and not well explained. And with the advent, the improvement, the development of new computer information systems and techniques, it was possible to perform more and more and more and deeper and deeper and deeper analysis, data analysis, and a new big, large, I would say, area named business intelligence appeared. In the theory, there is no one opinion about business intelligence and business analytics. For some researchers and scholars, business intelligence is this part of analysis that deals with data collection and simple reports. If we use this chart introduced by Davenport in the beginning of the 21st century, we can say that this first group, access and reporting, is what some people consider to be business intelligence. And the upper part, the most advanced part, is referred to as business analytics. There are some reasons for this, but in our class and most frequently and in general, business intelligence is considered to be kind of an umbrella, a broad category of applications and technologies that are used for gathering, storing, analyzing, and so forth, including dissemination, access to data. And the goal is to assist managers in making better decisions. So, according to this, business intelligence contains and covers many different techniques that start with standard reports answering questions like what happened, what is the case, and after that with new and deeper analysis and more explanations with ad hoc reports, drill down and queries that we know from Microsoft Access, and then going into the area of deep advanced analysis, where the statistical analysis is optimization. I wouldn't say that optimization is on the top. I would say that probably the predictive modeling is on the top, considering what is most advanced. But all these analytics, I would say that all of them are very advanced. And here we can find answers of very, very complex questions like what will happen next, or why is this happening? And in other words, techniques develop in new areas of analysis. Unfortunately, as we can see, most frequently used by information analysts and not too much by business managers, and very, very rarely by standard regular customers. Before we continue, I want to add a few more information. For many years, Gartner provides the so-called Magic Quadrant for business intelligence and platforms. They conduct surveys every year, and they prepare these Magic Quadrants that contains 4 quadrants about the challengers, leaders, niche players, and visionaries. I added this slide to explain each of them, and then a brief history of the business intelligence platforms, business intelligence and business analytics platforms. What is interesting is that if we start, let's say, about 10 years ago, in January 2011, we will see that there is a kind of a unification, or one, I would say, big, huge what is this? Is a chart. Let's say a big spherical object that covers the major groups and platforms, and most, if we can see, most of them are either in the leading companies or in the niche players, not too much about visions and visionaries or challengers, though there's a tableau. There was just the beginning of the development, and it was kind of a challenger. And now if we go year by year, what we will see is that next year we have even more spread in these 2 areas, niche players and leaders, still not too much in visionaries. And after that, things changed. Again, the whole population, or the whole companies, the whole number of companies gathered in one close object with not very big differences. But as we can see, companies started to spread and also go to visionaries, which we can find out if we go to 2016, when many companies move in the area of visionaries. As we can see, in this area are well-known companies as IBM, as SAP. You should remember it from CS301 class, or some companies that are not well known in other areas like Typical Software, MicroStrategy, but they're well known in business intelligence. And in the area of, in the quadrant of leaders, Microsoft and Tableau remain, but was not far away from the other companies. Year 2017 and 2018 introduced a lot of changes and spread between the companies, their goals, and their achievements. Microsoft and Tableau, they jump, and the difference between, the gap between Tableau and Microsoft and the other companies were very significant. if we compare 2017 and 2018, we'll see that again the number of visionaries from 2017 now either move to niche players or they try to catch up with the leaders, and not too big number of visionaries in terms of leading visionaries remain. 2019, now as we can see, many companies try to join the leaders and become leading providers, vendors of software. The current year return again a lot of uncertainties, meaning companies like SAP and statistical software, advanced software, SaaS return to visionaries. Microsoft and Tableau, they move even more, and as we can see, this competition between Microsoft and Tableau continues, but now Microsoft look to be the leading platform, and this is especially Microsoft Power BI, which we introduce and briefly explore in CS301 class, which provides tools, unfortunately, mainly for, I will return to this slide, to the first group of ad hoc reports, scoreboards, standard reports, and meaning tools for the first group or the lower analytical group. If we look at some other surveys from the last few years, we'll find out that this is true because most of the users, I don't know whether they're happy or not, but they're using most of the time dashboards, standard reports, ad hoc queries, and visual analysis. As we can see, all these huge bars, above 70% of the use of business intelligence techniques in platforms, though in their plans, this amount should be much, much smaller. And if we go deeper into analysis, we'll see that the picture changes. Now we have bigger plan than use, and especially this is true for data mining and predictive analytics, big data analytics, budgeting, planning, online analytical processes and analysis. And another survey about the importance of business intelligence and the trends for the future shows that, yes, data discovery and analytical data bases, predictive analytics, all these above 6 out of 10, meaning above 60%, if we use the term percent, are considered to be really important, but at the same time, as we can see from the previous survey, they're not in use. And the reason why not in use is simply because they do not exist. And now is the time to discuss and analyze what are the existing platforms and tools that can help, especially the area of business forecasting and predictive models and analytics. In In the beginning of business intelligence, and later on, with the advent of analysis, a new term, data mining, was introduced. If we check this chart, we'll see that advanced analysis, statistical tests of hypotheses, predictive analysis are considered to be the most advanced and sophisticated techniques. Now is the time to talk more about data mining. We, and I believe all of you, are now enough fluent in statistical analysis and basic techniques in business forecasting and predictive analytics. Now it's time to see what data mining is and what are the most recent achievements in the area of data analysis and predictive analytics. Data mining covers tasks that we know from information systems and statistical analysis, and there is nothing new. Looking at regression or classification, summarization, immediately you can say there is nothing new. That's true. The goal is to make things more and more advanced in automation. And if we use the MicroStrategy, one of the visionaries, platform, which is very similar, as we'll see after that, and it's used by all leading companies, and all companies agree to this general platform, the goal is that data, now here comes the issue, the big data. As we know already, big data is a challenge, a huge issue in contemporary data analysis. So, with the help of data mining software, the goal is to develop predictive models. These predictive models are used after that to generate reports which were developed after finishing are delivered to managers with the help of appropriate user interface, web portals, websites, emails, and so forth and so forth. If we check another dimension, another chart representing the three major components of business intelligence and platforms, we can see that, yeah, again, business intelligence is considered to be an intelligent interface that use database technology and techniques and data mining tools to develop useful reports and analysis that will assist decision makers and help them making better decisions. So we can summarize and say that data mining appeared as a tool to retrieve, to discover useful knowledge from these big data pool and databases and present them, deliver them to managers, business intelligence users that can use them and make better decisions. This was introduced in the end of the last 20th century as knowledge discovery from data or knowledge discovery in databases. The goal was, with the help of the so-called artificial intelligence. By the way, this was a goal that was never achieved, and though you can find out a lot of news about recent achievements, developments, but none of them could be considered as intelligence, or could be a tool, but not artificial intelligence. Why?
Well, I think there are some companies that are using AI to collect data, though.
Well, yeah, Jan, let me explain why, if we want to be more precise, AI is not real AI. There is a special test, the so-called Turing test, that is used to identify whether a platform or technology is artificial intelligence or not. Meaning, they ask there are several tests and questions, and nobody knows who is answering. Is this a human or a computer software? But let me explain. They never ever achieve 100%. And I would say that artificial intelligence or intelligence is the human. Well, I'll give you one very, very old funny case why it's impossible to have artificial intelligence. What is the major, I would say, the most important part of the human intelligence? This is the so-called free will or decision making, the freedom of choice, freedom of making decisions, right? This, if you check, you find out everywhere in all theories and so forth that the most important property for any intelligence is to make decisions. Okay, so what is this funny case? The funny case is that humans can make, and any other life intelligent, even animals, we can make decisions always. And the case is about a hungry donkey, and two haystacks. Well, no, they don't eat. They eat special. They call them in my country donkey thorns. Doesn't matter what it is, but the case is, if you have a donkey and it's in the middle between two haystacks that are absolutely identical, and the distance to each of them is the same, which one the donkey will select? Okay, let's make a kind of a discussion. What do you think? Which one they will select? The hungry donkey will select. What do you think? The right or the left? Any idea? Or I can make it more easier for understanding. Suppose you have a baby and you have two balloons in your hands, red balloons, and you show the baby, the small baby, these two balloons, and you put them just in front of the baby and the same distance, and they're absolutely the same. So absolutely very, very similar case. Which one do you think the baby will select? The left one or the right one? Anybody? Come on, guess. Can we make a decision like this? Well, the answer is yes. The explanation is uncertain. Meaning, the donkey or the baby, they can select either left one or right one, doesn't matter which one, but they will always make the selection. They will make the decision. If you have a computer software or, let's say, intelligent technology, And when they have to make decisions, they always like playing chess. Computer play chess based on algorithms. And if you play a chess with, let's say, at advanced level, it's almost impossible to beat the computer. Why? Because there are so many algorithms and, real life games coded that it's impossible to beat. The computer can go ahead in many rounds ahead of us. But I can give you a tricky approach to beat the computer at very advanced level. And this is the so-called Zeitnot. As you know, in playing chess, there is time, limited time. So, if you play a very stupid, you start, let's say, with the whites, and or even with the blacks, doesn't matter, but you play a very uncommon, even stupid move. The computer will start analyzing your move. And the more uncommon is your move, the more time it will take the computer to play. I remember when I heard this, it was told me by a semi-professional player, chess player, and we started playing at the highest level, and it took 42 minutes the computer to make its move after our first move. So, as I told you, we can beat it with Zeitnot. Well, if we play unlimited time, of course it will beat us. But the tricky moment is that the computer needs to analyze the information and based on given criteria to make decision. Why it's so difficult to play after we play uncommon, we have an uncommon move? Because there is no analog in its algorithms and cases. And if we ask artificial intelligence to make a decision and all choices, they're the same. Most of the time, or existing computers, they make what they can do is either to ask for more information or to get into a loop and never make the decision. Yes, there are some, this we'll discuss next time, training or similar to what we already introduced, the artificial neural networks, meaning algorithms that learn and try to improve, but they still learn from existing information. And because of this, it's impossible to develop computer system that is really artificial intelligence. Yes, they could be very smart in terms that these systems may have a lot of information. They can process amount of information that we cannot even think about. But still, this small part of the freedom of choice, the making decision, the free will, is not part of any artificial intelligence. And I'll finish this point of our discussion. If you remember, we watched part of a movie in CS301, War Games, and the female student asked, what was his name? I believe David. Yes, David. Ask him, oh, can the computer talk? And David answered, computer can do whatever the program it's to do. That's it. All computer artificial intelligence platforms are simply software, intelligent software. Yes, I agree, highly automated intelligent platforms. This I agree totally. But still not artificial intelligence. That's why if we go in, and you'll find in many theories or many other classes, the term intelligent tools or intelligent platforms is used rather than artificial intelligence. But let's consider and see what is the purpose of the knowledge discovery from data or in databases, and how this happened that intelligent tools were concentrated in this area. So here is one thing I want, though we don't study too much, but to remind you. In the 60s, 50s, 60s of the last century, there were two major areas in data analysis and predictive analytics. The theory-driven approaches, as you know, this is the regression analysis, mainly statistical analysis, and data-driven techniques, also known as machine learning, or using the so-called black box techniques. Well, as we know, both of them have advantages and disadvantages, and sometimes about the last 20 years in the last century was possible, and for the first time we saw unification between machine learning and regression analysis. And machine learning provided the automated part, and regression and other statistical analysis provide the analytical part. And if we check, this is the first chart introducing the knowledge discovery from data from a team, international team, Shapiro, Shapiro, Hayat, and so forth. And data mining here is identified and defined as a tool to discover, here is the definition, process or tool to explore and analyze large quantities of data, and the goal is to discover meaningful patterns and rules. Very, very close to this is the area of the predictive analytics. And though it looks most of the time that predictive analytics could be considered as an area in data mining, at the same time, if we just analyze the broad definition of predictive analytics, this is a big variety of techniques from statistics, machine learning, and data mining. Not everything in data mining is statistics. And not everything in predictive analytics is data mining. And not everything in data mining is predictive analytics. So it's a little fuzzy, but we can say in general that, yeah, data mining is broader, broader definition and area than predictive analytics. So let's say that we'll consider that predictive analytics are just part of or combination of techniques, tools from statistics and machine learning, and their combination, this is the data mining, with the goal of, here we'll return to data mining task, to identify rules, discover rules and knowledge. This could, And the goal, of course, the goal is for assisting in making better decisions. That means this general data mining task that exists long time ago, this task also involves some prediction, especially in regression analysis, in dependency modeling, in change and deviation detection. And as I mentioned, the new step here is to automate all these processes, all these existing techniques. So far as we did in regression analysis and business forecasting, we use Microsoft Excel, and we also introduce Gretel software, very advanced software, but still not enough automated. That is, with the development of data mining techniques in predictive analytics or predictive modeling, was possible to develop or to introduce new, more and more automated tools to develop forecasts in different areas, including business forecasting. The presentation was larger, but after analyzing the differences between old and new chapters, I realized that the existing chapter 10 finished here, and after that there are some examples. These examples are basic examples, meaning not very recent. The idea was to show the first examples in data mining and predictive analytics using business intelligence platforms. And in the next chapter, we'll talk about, or in more details, we'll explore data mining and how to use data mining techniques in predictive analytics. I'll stop my presentation here, and we'll continue next week with chapter 11, when we'll explore in details data mining and predictive analytics. As I told you, the case is very, very big if we want to cover all these advanced techniques that we introduced in chapter 8, 9, and now we will start with the data mining as far as Gretel could be considered as, it's not really data mining tool, but we can call it one of the basic platforms that was developed and allow automation in predictive analytics. So I will stop recording.